So we have looked at our first method of factoring, greatest common factor, which we can use regardless of how many terms we have. We have 2 terms, 3 terms, 4 terms, 5 terms. Heaven help us if we had 6 terms, but greatest common factor can be used regardless of how many terms we have. This next method of factoring we're going to use, this factor by grouping, we need 4 terms. So in order to use this method grouping, we need to have 4 terms, okay? And some of you might know different methods for doing this. I like to use a method that involves a box. It helps keep our information organized and helps us keep our plus and minus signs straight. So I'm going to go ahead with my box method. If you like it, go for it. If you have another method that you know that you like better, you do not need to learn this box method. You can factor with the method that you already know. So first off, let's take a look at our terms. 1, 2, 3, 4. So we have 4 terms, so we can use the box method for this. Now we need to check for the greatest common factor. Is there one? 4 and 20, we have a 4 there, but back here, 3 and 15, we can't use a 4. So back here we can use a 3 with the 3 and the 15, but we can't use it for these 2 terms up here. So no greatest common factor in terms of the coefficients. X squared, x, so x is looking good. However, no x back here. So we can't pull out an x as a greatest common factor. And then these 2 back here have y's, but up front these 2 don't. So there is no greatest common factor here because we do want to check and make sure that if there's a greatest common factor, we pull that out first. So there is none. So we can go to our factor by grouping now. So as I said, I like to use a box to do this. And since we have 4 terms, we make a box that has 4 squares in it, 4 cells in it. And what we do is we take each of these in order and put them in our box here. So we have 4x squared, then we have plus 20x, then minus 3xy, and then finishing up, our last term goes in this box down here. We have minus 15y. So we take our 4 terms, dump them inside the box, the 4 boxes. Now, what we do here, this says we're going to factor the GCF from the first column. So we're going to factor GCF, first column, factor GCF going second column, and then we're going to do the same thing with the GCF going across the first row and going across the second row, the bottom row. So this is the procedure. So greatest common factor going down, 4 and 3, there's nothing in common in terms of the coefficients. X squared x, we have an x. That's in common. Moving over here, 20 and 15, we have 5 in common. So I put the 5 there. And now x, y, there's no variable in common, so it would just be the 5. So there is our first factor. And now we need a plus or minus sign in here. We know we need a plus or minus sign. So to get that, we go to the box this 5 is sitting on top of. 5 is sitting on top of this plus 20. So this is going to be a plus sign in that factor. Now we repeat, but now we're going across in the rows for the greatest common factor. 4 and 20, greatest common factor is going to be 4. And then x squared x, greatest common factor is x. Moving to this row, 3 and 15, we ignore the signs. When we're looking for what's in common numbers, ignore the signs. Just look at the basic numbers. 3 and 15 is going to be 3. And now we have x, no x there, but we do have a y in both, so it would be 3y. And there is our second factor. Again, we need to have a plus or minus in front of this 3y. So how do we find what that is? We go to the box this 3y is sitting in front of. It's sitting in front of a negative 3, so this becomes negative. So there's our factors. So this looks a little weird, written vertically, so we're going to rewrite this. It's x plus 5 times 4x minus 3. Notice the answer to these factoring problems looks now like two binomials, right? Two binomials being multiplied. Instead of one parentheses now, we have two parentheses. So these answers look different than our greatest common factor. Next one, 1, 2, 3, 4 terms. So we qualify for the grouping. And we look to see if there's a greatest common factor, x, but no x's back here. And these can be 5 and 45. Yes, they have 5 in common, but this doesn't and this doesn't. So there is no greatest common factor we can pull out. So we can just take our information and put it inside the box. So starting here, xy minus 5x plus 9y minus 45. So we have our 4 terms in the boxes. Now we're going to find the greatest common factor going down. xy, 9y, what's in common is y. 5x, 45. Between the 5 and the 45, it's 5. This has an x, this doesn't have an x, so we can't use the x, it's just going to be the 5. There is our factor. 5 is sitting on top of the box where this is a negative 5, so this will be negative. And there's our first factor completed. Going across now, xy, negative 5x. x, so we can pull out an x, and that's it. This has a y, none y here. This has the 5, but there's no 5 there, so we're done. It's just the x. Moving down to this row, 9y and 45. 9 and 45, greatest common factor would be 9. And now y, but no y, so it's just the 9. So there's our factor. We need a sign plus or minus in front of this 9. It's sitting in front of the box where 9 is positive, so this would be positive. So our factors are y minus 5 times x plus 9. Again, the answer is two binomials being multiplied. And now our last example, 1, 2, 3, 4 terms. So it's eligible for grouping. And if we take a look at our information, xn, but no x's back here, and then y's and y's, but no y's here. So there is no greatest common factor to be pulled out. So we make the box. X to the n, y to the n sits there, minus x to the n, continuing, plus 2y to the n, and then finally minus 2. Some of you are probably not so happy with these exponents. What's going on here? No x squared or x cubed, x to the n, really? It's okay. We can deal with this. Greatest common factor going down. X to the n. We don't have any variable x here, so we can't do anything with x's. Here we have y to the n and y to the n. Yeah, we don't know what n is. Maybe it's 2, maybe it's 15. It doesn't matter. N is the same there. The exponent is the same, so that is our greatest common factor, y to the n. Moving to this column here, x to the n and 2. There is nothing in common here. Agreed? This doesn't have x's, this doesn't have a coefficient of 2 or anything divisible by 2. So when there is, I don't know that we've had something like this before, but when there is no common factor, at least it can always be a 1. So that's what we're going to write there, 1. So there is our factor. Again, we need a plus or minus in front of this 1 because 1 is sitting on top of the box with the negative sign. The negative sign goes in there. And now going across xn, yn, and here we have xn. So we can see x to the n is in common. So we can pull that out. And to repeat what I said about the y's, it doesn't matter we don't know what n is. It's the same n exponent in both. And then down here in this last row, 2y to the n, and then 2, we can see this 2 coefficient of 2 is the same. So we can write that out in front. We need a plus minus in front of this 2. 2 is sitting in front of the box where there's a plus, so we put the plus sign there. So our answer would be y to the n minus 1, x to the n plus 2. Whoops, probably not one of your favorites, but it's something that you can handle.